Hello everyone. In this video, we'll understand how do we derive the derivatives of various trigonometric functions. To start with, first we are going to derive about if the function is sin x, if y equal to f of x equal to sin x, then how you will find dy by dx using first principle method. So based on the first principle method, the derivative is defined as dy by dx equal to limit h tends to 0 f of x plus h minus f of x divided by h. So here f of x is sin x, so f of x plus h will become sin of x plus h minus f of x is sin x, whole thing divided by h. Now we will be using a trigonometric identity, which is sin A minus sin B is equal to 2 times cos A plus B divided by 2 times sin A minus B by 2. So we will be using this trigonometry to expand the numerator of the above limit. So now dy by dx will be limit h tends to 0, 2 times cos x plus h minus x, because here it is a is x plus h, b is x, whole thing divided by 2, wherein we can cancel this x and this x, and then sin of a, sorry, this should be plus, sorry, it will not get cancelled, a plus b, sorry. So here it is minus x plus h minus x divided by 2, the whole thing divided by h. Here this x and x are getting cancelled. So this will be now written as, we will split this limit into two limits. One is limit h tends to 0 cos of x, sorry, here it will be 2x plus h divided by 2, that is one limit, and then multiplied by another limit. See, what are all we have not taken? We have not taken this 2, so that 2 will come in the numerator, and then sin of h by 2 is not being considered, and then divided by h. Now again this will be dy by dx is equal to limit. Now I think we can substitute the limit here. Apply the limits, means h is 0, that means this will become 0. You will get 2x by 2. So let me, this is nothing but cos of 2 times 0, sorry, 2 times x, 2 times x, or I will simply write 2x plus 0 divided by 2. I mean, after applying the limits in the first limit. Then the second limit will be modified as limit h tends to 0, sin of h by 2. I'm going to bring this 2 to the denominator, so it will go to the denominator of h. Now we will be using this limit, which is limit x tends to 0, sin x by x is 1. By using this useful limit, the second limit can be considered as 1. So this will be now 2x plus 0 is 2x, 2x by 2 is only x, so it is cos x multiplied by this limit, whatever it is nothing but 1. So this will result to cos x. So the dy by dx of sin x is cos x. I'll say therefore d by dx of sin x, that is the first derivative of sin x, is nothing but cos x. Here it is, if y equal to f of x equal to cos x, then how will you find dy by dx using first principle method? Again, the definition of first principle is the same. Dy by dx is limit h tends to 0. It will be f of x plus h minus f of x, whole thing divided by h. That will be rewritten as f of x plus h will become now cos of x plus h minus cos of x divided by h. So we will be now using a trigonometric identity which says cos A minus cos B will be negative 2 times sine of A plus B by 2 times sine of A minus B by 2. So we will be using this in the numerator of the above limit. So this is equal to limit h tends to 0. Numerator will now become minus 2 times sine of, here A is x plus h and B is x divided by 2 times sine of A, that is x plus h, minus B, which is x divided by 2, the whole thing divided by h. So this will become now, again we will be splitting it into two limits. One is negative limit h tends to 0 sine 2x plus h divided by 2, that is one limit, and then another limit will be limit h tends to 0 2 times sine h by 2 divided by h. This will become now, in the first limit we will be applying this, applying the limits. By applying limits, this h will become 0, means sine of 2x plus 0 here divided by 2. Okay. Then here I will modify this limit by bringing the 2 to the denominator, which will go to the denominator of h. So sine of h by 2 divided by h by 2. That will be now, here 2x plus 0 is 2x. 2x divided by 2 will become x. So it will be simply minus sine x. And this we had already seen in the previous derivation. It is nothing but 1. So you get minus sine x. Therefore, we can conclude that d by dx of cos x is nothing but minus sine x. That is the proof of this. In this, we need to find out the derivative of tan x. If y is equal to tan x, then find dy by dx. So here, y is nothing but tan x, and that can be written as sine x divided by cos x, which means we will be using quotient rule, that is dy by dx will be v du by dx, means quotient rule, you assume this as u, you assume this as v, which means v du by dx, that means cos of x d by dx of sine x minus sine of x, that is u, d by dx of v, that is cos of x. The whole thing divided by v square, which means it is cos square x. And that is cos of x, and d by dx of sin x is cos x, minus sin x, d by dx of cos x is minus sin x, whole thing divided by cos square x. So this will become now cos square x plus sin square x divided by cos square x. Numerator sin square x and plus cos square x is nothing but 1 divided by cos x square, and that is 1 by cos x is nothing but secant x. That means this will become secant square of x square. So that means the dy by dx of tan x is secant square x. This y is equal to cosecant of x, then find dy by dx. So given y is cosecant of x is nothing but 1 by sin x, which means dy by dx equal to, again we'll be using quotient rule, that means denominator which is sin x, d by dx of 1 minus 1, that is numerator, d by dx of sin x, the whole thing divided by square of the denominator, which is sin square x. So that will be now sin x, d by dx of any constant will be 0, minus 1 times d by dx of sin x is nothing but cos x, the whole thing divided by sin square x. So this is nothing but 0 minus cos x, which is minus cos x, divided by sin square of x. That can be splitted as minus cos x by sin square x can be written as sin x into sin x. So cos x by sin x is nothing but, we are considering this together, and then here we'll be considering 1 over sin x. So if I do that, I get negative cos x by sin x is nothing but cot x, 1 by sin x is nothing but cosecant of x. So that is the derivative of cosecant of x. If y equal to secant x, then find dy by dx. So y is given as secant of x, which is nothing but 1 by cos x. So that means dy by dx will be denominator, that is cos x, multiplied by d by dx of the numerator, which is d by dx of 1, minus of 1, that is numerator, d by dx of cos of x, a whole thing divided by cos square x. So that will be now cos x into d by dx of any constant will be 0, minus d by dx of cos x is minus sin x, whole thing divided by cos square of x. So this is nothing but a 0 minus or minus, it becomes plus sin x by cos square x can be written as cos x into cos x. So sin x by cos x is nothing but tan x, and then 1 by cos x is nothing but secant x. So the derivative of secant of x is tan x into secant x. If y is equal to cot x, then find dy by dx. So y is cot of x, and that is nothing but cos x divided by sin x, which means our dy by dx will be sin x, that is denominator, times d by dx of cos of x, minus numerator, which is cos x, d by dx of denominator, which is sin x, a whole thing divided by sin square x. Therefore, dy by dx will be sin x times d by dx of cos x is minus sin x, minus of cos x, d by dx of sin x is nothing but cos x, whole thing divided by sin square x. So the numerator is nothing but minus sine square x minus cos square x divided by sine square x. So numerator, I can take negative sign outside. So I can rewrite it as sine square x plus cos square x, whole thing divided by sine square of x. Now sine square x plus cos square x is nothing but 1. So we can rewrite this as minus 1 divided by sine square of x. And 1 by sine x is nothing but cosecant of x. So we can write this as minus cosecant square of x. That is the derivative of cot x.